Hi, this is Kevin from Kevin's Classroom. I'm going to consider this. We're going to look at displacement. They have given us this track over here, and this is a quintessential problem, A, and they've told us that B is directly opposite this, and they've told us that the track is 400 meters, 100, and all the way on the outside are also going to be 100. This is 100. And that is 100 over there, which means I have to work out what the radius is, and we do that quite straightforward. They have asked us, we run from A to A, what is the distance and what is the displacement? So if we run from A all the way around to A, you can see that the distance I have run, if I'm going down here, okay, like this, is I have run a total of 400 meters. But what is my displacement? My displacement is 0. Why? Because displacement is measured from the point where you started. And we're back where we started. The next question is they say, right, I run to point C, and which means I am now actually that far away. This is my displacement over here, my delta x. And no, my displacement isn't 200. I have to work out the straight line dimension. The A to B distance, right? Or rather, the A to B distance is going to be 300. So if I go A to B, the distance is equal to 300 meters. You can see that because I've gone around the outside like that until I get to B. But what is my displacement to be? My displacement is actually this piece here, and A to B. My delta x is actually just going to be the diameter, isn't it, of that circle? And I calculated that earlier. The diameter is 63.66. 63.66 meters. And I would do that from the equation for a circle, where the circumference is 2 pi r, and I would work out what r is and then double it to get d. Then the last bit is the orange bit, the red bit, where they say, right, what is my distance from A to C? My distance is going to be equal to 200 meters, isn't it? But what is my A to C displacement? Now I have a problem, because with displacement I have to put in a direction. So here I would say south, because it is straight down from me, or a minus direction in the y-axis. If I now move myself onto my red one, my displacement, not my dips, my displacement is going to be the distance delta x, which is shown above on the screen, and delta x in that case is going to be equal to, it's Pythagoras, so we have to say that is going to be equal to, and our baseline is 100 squared plus my 63.66 squared, and all to the power of a half, which is the square root, and the final answer is 118.54 meters. So I'm just going to put those numbers on there. This across here, the delta x that we had is 63.66. But now I also have to put the angle. And the angle of this thing, and most of the time, guys, you do actually use this. Most of the time, it is going to be the arctan, and it's arctan of 63.66 divided by 100. And if you put that in, you're going to find 32.48 degrees. 32.48 degrees, and it's to the south of east. To the south of east. Thanks for watching. Have a great one. Cheers.